Counterexamples. Kind of already touched on it in the section about conditional statements, and that we can test conditional statements by using counterexamples. If someone were to tell you something is true and then you were able to tell them something that was also true, then it would be considered a counterexample. So whenever we're talking about isolating things, like if we have fruit growing on a tree, then that fruit is an apple. That's not an incorrect statement only because apples do grow on trees, but there are plenty of other fruits that grow on trees. Any fruit that you said that was not an apple would be a counterexample. Let's take a look at two examples. If a number is a perfect square, meaning that it's going to be an integer times itself, typically a whole number like 2 times 2, 3 times 3, 4 times 4, 5 times 5, and then you have that as a product, 25, we'd know that the square root of 25 would be 5. Nice and simple, easy and clean. 99 does not work out that way. 21 doesn't, and 10 doesn't, but 36 does. Square root of 36 is 6 times 6. And we know that if it's a perfect square, which is 36, then it has exactly 3 factors. That means whenever we break it up into a factor tree, then any combination we make of that, there's only be 3 numbers that multiply to make 36. Well, with 36 being a perfect square, I tested that out. So I wrote down all of the factors for 36, and I came up with way more than 3. So if a number is a perfect square, then the number has exactly 3 factors. I provided an example by saying 36 is a perfect square that has more than 3 factors, making that statement not true. So the perfect square of 36 is proof of a counterexample. Take a look at the next one. If a number is prime, then it's odd. Okay. Well, 13 is prime and it's odd. Okay, sounds good so far. 2, that's prime and an even number. Okay, let's just hold on to that. 8 is not prime and 9 is not prime. So if 13 and any other prime number you can think of, 17, oh man, it's odd. 23, oh, that's odd. But 2 is the only even prime number, making this statement, if a number is prime, then the number is odd, as being false. So by providing a counterexample of something that's true that is outside of the statement being given, that's called a counterexample. Let's take a look at 3 more. So if a sport usually involves a helmet, then the sport is cycling. Okay, so what we're thinking about is people that are in the sport of cycling. Yeah, it's true. I always see them wearing helmets. I see them on TV, everything. On the streets, they're always wearing helmets. Okay, it sounds like a true statement. Can I think of anything else that if you are in a sport that involves a helmet is not cycling? Yeah, I can think of a couple. So tennis, no, you don't wear a helmet for tennis. Swimming, no, you don't wear a helmet for swimming. Basketball, no, you don't. Skateboarding, yes. The professional sport of skateboarding would be something that is not cycling that you wear a helmet for. That would be a counterexample to say that statement's not completely true. On to the second one. If a food is pizza, then it has meat on it. So if a food is pizza, so we're talking about if something is pizza, then it has meat on it. Well, the first example right here, vegetarian pizza, that's a pizza that does not have meat on it. So there is your counterexample. Pepperoni pizza has meat. A sandwich is not a pizza and it has meat on it. And then a salad. Ooh, if a food is a pizza, then it has meat on it. Well, we could have a salad, but it doesn't have meat. But what's the problem with this? It's not a pizza. So this is going to be, again, another one that's not going to be a go for us. So we're thinking about things that are true, that fit into the parameters we're being given, but we're providing another example to say it's not completely true because of this. If a 3D solid lacks vertices, then it's a sphere. So something that's 3-dimensional and it's a solid, but it doesn't have any vertices. Well, cube, it's got vertices. No go. Rectangular pyramid, vertices. It's got pointing edges and corners all over it. A sphere, well, that fits in nice because that's part of the statement. So this one's good. But the one that would be considered a counterexample would be a cylinder. This does not have vertices. It does have edges, though, and they go around the circle where the rectangle wraps around the two circular bases. So idea, and it's very easy to overthink counterexamples and conditional statements. Try and find the answer that best suits the statement to be a counterexample.